Very good morning, dear students. Today's session, we are actually starting with one of the topics which can be taught at the start or at the end of this particular course. Personally, I feel this topic has to be taught at the start, but uh, ultimately you have to have a basic understanding of this planning and uncertainty. So this particular topic is kept at the end. So what do you mean by this design of experiments? So this is the last module 10, which comes under the design of experiments. So as an experimentalist, as a measurement engineer, as an engineer who wants to do measurements, you have to be very careful with the protocol that you want to use for measuring. Or when you design a particular uh, system for measuring a particular variable. Okay, so what is the design protocol that you want to use? So far, what we have done is we have studied about the experiment planning, uncertainty analysis applied, uh, are related with instrumentation, methods of measurement, and very important thing which we could not finish is the experimental reporting. How do you report the experimental results? Which I think, if time permits, we will try to cover it up. But I don't know how much time we have left. Me and Satyananda is discussing about whether to go for a few more experimental measuring devices or just to finish off with the experimental report. That means when you have done an experiment with measurements, or when you calculated some measurement, when you measured certain variables, how do you report the output to the external person? It's like a record submission to the in an academic setup for a particular lab. Okay, how do you write? What are the things that you do that you have to be very careful, and what are the things that you should not do in a report for analysis? So apart from that, the very purpose of this chapter is to bring some of the information together to form an overall protocol for the execution of the experiment. Suppose, as a design engineer, you are asked to design an experimental center. So, is there any methodology to actually design a particular setup, or what is the steps that are involved? What is the first step? What is the second step? What is the third step? Which we can use for any experimental setup design, experimental setup design. So this protocol is will never see, we can never say that it is complete, as each experiment is different, but more or less we will try to relate depending on the experimental setup. In general, it will be, if we generalize it, it will be the same for most of the experimental setups. So the present class is basically on how do we design the experimental setups, and what is the protocol or what are the steps involved in general while developing the experimental setups. So before going into the experiment, what is basically means, what is the basic definition of an experiment? Okay, so someone asks you, define experiment. How do you define it? An experiment is a test, maybe one single test or a series of runs, or it can be the same experiment we run for several times, in which where we have purposeful changes. So that means we are actually trying to vary the input variables of a process or system, and what we are observing at the as an output for the varying inputs. Okay, and explaining the reasons for those changes in the output responses logically. So we have to tell that what is the reason why for a given change in an input, how the output is changing, for a given variable change, why the output is changing, and what is the relation between these two, is what is explained in an experiment. So is the reason why we do an experiment. Okay, so it's like a cause and effect relationship. What is the reason, cause, and what is its effect? So what is the relation between these two is basically standardized by an experimental thing. The experiment may be performed a single time, or it may be done on several runs for several times. The same procedure may be repeated for several times. And finally, we are finding out what is the cause and what is the relation between the cause and the effect. Clear? So it is very, very important. So when we are finding a relation between cause and effect, we have to be very careful in planning and conducting experiments and analyzing the data to obtain valid and objective conclusions. So whatever you are proposing after the experiment has been carried out, so you have to be very careful to plan and conduct the experiments. While planning and conducting the experiments, you have to upfront take so many precautions to make sure that whatever the conclusions you are giving that makes sense, or that is basically following the physical laws that are available. You cannot say something which doesn't fall under the physical laws that we have been studying for over a period of time. So it has to be logical, it has to be believable. Okay, so for getting such conclusions, a carefully planned experiment is a must.
Excuse me, sir. Just to confirm, you aren't changing the slide now?
I'm not changing. I'm in the
Yeah.
second. So are you not seeing experiment? What is the
No, sir.
title?
We are on the first page, a design of experiment module 10.
Don't know why this happens. I'm actually changing the slide. So now what is that you are seeing experiment thing?
Yes, sir. Now we are seeing it, experiment, yes.
But when it comes to here, now it is not changing, right? You are not seeing any
No,
change.
it is not changing.
No,
We
sir.
are seeing the experiment page only.
Now, is there any change?
No, sir. Same
No, sir.
experiment page.
So I have to share the screen only. Otherwise, I don't know why this window thing is not working. Even in a window, it has to work. Now, can you see now? Experiment slide.
Yes, sir.
Yeah. So I hope you have understood what I tried to say. It's basically finding the cause and effect relationship. I just spoke about the experiment definition here. This is the experiment. And I'm trying to tell you what is the importance of it, of a carefully planned experiment. Why it is required is we have, in order to make logical conclusions which can be believed by everyone. So experimentation plays a vital role in technological commercialization and product realization. So you have an idea, okay? You say that you got some idea. So basically, a vague idea which is dependent on physical laws, probably. So whatever the loss, is it increasing? So it will, the other variable may, if x increases, y variable may also increase. That's an idea that you have. But uh, how do you make sure that the third person for whom you are explaining your project, how do you convince him? Can we do that with a basic numerical simulation? So you may say that, sir, nowadays computers are advanced, so can we do a numerical simulation and explain them? That's true. But for a numerical simulation, it's just basically a mathematical model. Okay. I want to explain you what is a mathematical model. So the process is pretty simple. So you have the physical phenomena, for example, uh, as in a closed beaker kind of a thing, you have a piston. Okay? You have a piston, and there is some gas inside. And when you apply some force to the downwards, when you apply pressure, your volume will reduce. When you increase the pressure, your volume VOL will. So you know this particular phenomenon. So based on this relation, if you can write these two variables as a relation by a mathematical model. So you say that you have a mathematical equation which tells the relation between these two. Okay. So a mathematical relation. in order to get to this relation also, pressure is inversely proportional to V, you have to do this experiment, correct? Unless you do the experiment, you cannot say that this relation will come. Okay? So this observation has been made by a particular experiment. So what this relation, whatever we are following here, we say that when temperature is kept constant. How the temperature is kept constant? How do you make ensure? By insulating the sites. So this is the critical part that you have to carry. So in this particular experiment, your insulation has to be absolutely adiabatic. It cannot allow any transfer of heat so that this relation holds true. So in an in a physical phenomena, okay, you have done some experiments, and from that you will have the mathematical relation. So after looking at this, suppose if you want to find out what is the relation between temperature, for example, so you also do you also know from this experiment you can do right now using this mathematical relations. You can form a code. The repetitive thing you are writing a code. Okay, so a program you are writing. And that program will help you with the help of this computational fluid dynamics or control volume method, whatever the numerical simulation model. You are trying to solve these equations, okay? And we are running some numerical method, numerical model, numerical simulation you are carrying. So numerical simulation is nothing but you are trying to replicate the physical phenomena that is happening in a computer. So from this you will get an output. But how far you are sure that this is the same output you are getting even in the physical world, the real world. So for that, we have to have experiments. Unless we validate, that means whatever this P is inversely proportional to V. If we are not able to show that in the simulation, if you have to clearly show whatever the experimental thing that you have done over here, the same thing you have to do in the numerical simulation, and now you have to show that the same law holds. Okay, and then it is this part of this work we call it as validation. Okay. After doing validation, you can do a numerical simulation and make others believe. Okay, so without this experimental work, you will not have anything to validate that your numerical simulation is correct. So that is the most important part. And nowadays with research and all, publications with without experiments is becoming difficult because people won't believe your numerical simulation very easily. Because suppose if you take answers and fluid, which you might have done in your experiment, it's like a black box. You don't know what are the exact equations that are being solved unless you open it and check everything. So it's already written program, and only you see the graphics inside and some values you have to give as an input. So what are the equations being solved, what method is used, you don't know, you just use some options. So based on that it will solve. If another person gives a different meshing, okay, when you come to different discretization of the schemes, if you based on your discretization, your results will differ. So how do you ensure that it is giving correct results? For that also you need to have experiments. So the next question is, sir, suppose if we want to have experiments for every validation, for every numerical simulation, what is the use of a simulation? The use of a simulation is once you made sure that your numerical simulation is valid, you don't need to do any further experiments. For every other values, you can just do a simulation by varying the probable variable, and then you get this. That means once you validate it, that means your numerical model is correct. Then people are assured that whatever the results that you are giving out of your numerical simulation is correct. So when compared with experiments, numerical simulations are not time consuming because fabrication and designing things are avoided. So obviously your time will be saved. Okay, so it is basically when you want to commercialize, that means when you want to make money or profit out of a product. So first you have to realize a product, and for that this whole experiments are very important. And once the product is realized, so that technology we can make it profitable. So that is called as technology commercialization and product. So for doing all of this, we need to have these experiments. So it's not normal vague kind of a things. They have to be very, very, very precise while doing these experiments. Okay, so you have to take various things into consideration, and generally, what are the in general for every experiment? What is the steps or procedures that you follow? Is what we are going to see today. Okay. Any doubts up to this? Okay. So now, first of all, I would like to show you different types of experiments, which we have already discussed very briefly in chapter 2. And at this point of time, we are actually choosing to expand the categorization of these experiments. Okay. So what kind of experiments that we have? Just we are classifying them into 9 types, just for the sake of discussion, to understand the basic differences between the different kinds of experiments that we are going to perform in the real world. Okay. So, and in addition also, we are also trying to show you experimental characteristics which may or may not be applicable to each of these categories. Okay. So the characteristics, I generally they have, I will show you the next title that was given in the textbook with 9 subheadings, like 9 different types of research that are possibly carried out. Okay, but I am trying to make it them into basically 4 kinds of experiments. One is the fundamental research. Okay, first one is the fundamental research. Second one is the developmental work. Third one is testing based on codes, etc. And fourth one is just want to know. It's out of curiosity. Okay? So how do we differentiate these 4 types of experiments? Okay? So first kind of experiment is what we call it as fundamental research. That means it involves basic research, which is very, very specialized, and it requires experts in that field, to actually execute that kind of research or experiment. Okay, so we need expertise or expert people to conduct experiments in this particular kind of research, and the design, especially the design of such experiments, is highly variable. That means it is not exactly the same. Okay, it may differ from person to person, from expert to expert, depending on what inputs he's varying and what is the output he want to analyze. So based on that, the design of these experiments will vary. However, the protocol in general, whatever the protocol that we are going to lay out in this particular class, it can be applicable to these kind of projects, depending on the experts in the respective fields. Okay, but don't misunderstand that it doesn't need to follow the same procedure. Means we will not take any information from the previous research and all. We will take the previous what outputs were taken from the previous research where others have done. So it might have been done by some other researcher who is an expert in his own field, what his insights are and how he built his experimental setup, and taking his inputs, taking the inputs from that particular project, we will carry forward to while designing the our experiments for the different variable measurements. Okay, so in short, if I have to tell you, it is nothing but an expert is required for carrying out the fundamental research. I will show you the table that I am talking about. So here, it is the fundamental research, company or proprietary or government classified. Second one is fundamental research open research. There are 2 things. One is a company proprietary or government classified. Second one is fundamental research itself, but it has open research. So what does that mean? So both these kind of research requires expertise people to carry out the research. This is the fundamental. But what is the difference between these two? In order to distinguish these two kinds of research, we need some variables or some characteristics of this research to actually differentiate between these two. Correct. So I have given a few of the constraints based on which we are classifying the different kinds of research here. The first one is type of output publication or reports. Okay, so I will explain the important ones. Others you can go through them, because if I keep on explaining this thing, it will completely take out our time. So what is the output publication? You have conducted an experiment with an expert, so it comes under fundamental research. So once you conduct some experiment, what you are going to do with the output when it comes to publication or report? So can it be open to everyone? Can it be very hidden kind of a thing? You cannot. There are restrictions that you cannot show it to anybody. So what kind of restrictions are laid down on this kind of experiments? So based on output publication or reporting, we are classifying the first and second as, in the fundamental research, company proprietary. That means it is owned by a particular company, or government classified, or only government is owning this kind of research. Okay, so this kind of things, the results, for example, ISRO, whatever they are providing, those results are not open to everyone. Correct? It is government classified thing, so it will not be open to everyone. So but how they will share the knowledge? How do they share the output that comes out from the expression? It is based on internal reports. So inside the company or inside the government only, the internal reports in the form of internal reports. That means they will not come out to outside, with portions possibly for journals. So it's not completely outside, but only a few portions. In general, they will not give it out. It's like a proprietary item. So basically, the output dissemination, the knowledge of the output dissemination is basically by means of internal research. It's not open to everyone. So the results that we get is not open to everyone. So they are highly confidential and they cannot be given out. So such kind of research which requires expertise and the outputs are not allowed to be published outside, it's only for internal reports, then that classification is called as fundamental. So in a fundamental research, we cannot give the outputs to the output results, we cannot give it to the outside. When it comes to fundamental research, it can be, you can see clearly here, these are open results. So nobody will ask, nobody will constrain you to keep them confidential. It can be published. For example, whatever the work, whatever the project that you carry out in your final year, what you do, that results, if they are found to be very good, then you can show it to the world by journal publication, peer reviewed journal publication. You can, it's an open access. That means anybody can access knowledge about the outputs for varying different inputs. Okay, so that is what we call it as type of publication. Based on type of publication, we are classifying them. Okay, so second thing, presentation requirements, special meetings, etc. So are you required to present time to time about the requirements and what needs to be done? How do you do that? What are the output that you have? How do you improve that output? So for that, in a fundamental research of proprietary in nature, internal and external meetings are only allowed. Whereas fundamental research output, we have professional society meetings like IEEE meetings or IMechE, that means International Mechanical Engineering Congress and Exposition. This kind of societies meetings, that means conferences, you can say. So in conferences and all, you can directly go and present your results and seek the inputs from the viewers or participants. So this kind of thing can be possible in fundamental research open results, but not in fundamental research proprietary. So the third one is experimental operators designed outcome or objective not specified. So sometimes your experimental setup design or outcomes may not be specified both in both the fundamental. We don't know what exactly is going to come out of. So that may not be knowing. It's not that you know it completely. So outcome known or anticipated, no, we don't know how this in fundamental research we don't know, because it's the nature is fundamental. So you are not sure what is the outcome. Okay, method or procedure known, outcome unknown, or surprises anticipated. Sometimes we know the method of procedures, or sometimes the outcome is not is even though it's not known properly, but we may anticipate some sudden surprises, okay, in the fundamental research. So whatever you think is not going to work, it may suddenly work. Okay, analysis and theoretical requirements that vary to that those are generally variable. Okay, they vary from experiment to experiment. So whether you require an uncertainty, this is required in every experiment in general. Uncertainty, what is the deviation from the actual value? What is the error involved with this is very, very important. This uncertainty analysis has to be carried out, and it has to be explained to the whatever internal reports are, to the journal articles. To people will ask what is the deviation from the actual value. So this analysis has to be carried out, and it's not a very difficult process. Whatever we have seen in the previous chapters, in the second chapter, what you have learned, that should be enough. Even though some of the experiments may require the statistical methods and all has to be used, and it's an in-depth process, but in general, the simplest methods that we have discussed in this particular course are more than sufficient for carrying out the uncertainty analysis for fundamental research, both proprietary type or open research. Whether personnel require special background? Yes, we require people of high expertise. Significant involvement of other groups of people? We don't know. We don't necessarily need other groups to be involved and all. So another thing, another classification, novel experimental design is required. It varies. Mostly we don't need novel experimental designs and all. We generally don't require, only depends on whatever has happened. We will try to modify that slightly, and then we will find out the outputs. So special instruments required are off the shelf. Usually they are off the spells. So you may require and experiment designed or execute only. Experiment designed are already existing design. We can continue with the fundamental research. No, each time whatever the research that you are carrying out, based on that you have to design new things. It's not that one setup is made ready for all the experiments you can use. It's not possible. Okay. So most of the times the fundamental research involves newer things to study, newer things to be studied. So it's not a redundant process like the same experiments have to be conducted again and again. Okay. That's not is what is required or what is expected in a fundamental research. Expenses limits or budget restraints, they are generally not very they're in general very generous, this kind of fundamental research, because it generally gives unexpected results out of that. So we generally have modest restraints on budget. So that means constraint. So budget is given, but some moderate kind of limitations are laid on the budget. Time constraints, generally it's a relaxed, we don't have any time constraints. So for example, whatever the research that we are carrying out in an academic setup, they all comes under this fundamental research. If you want it very simple way to understand. Environmental constraint, this is most important. See what kind of experiment that you are carrying out, whether it is harming the environment or not, you have to explain. Even when you apply for a funding for government agencies, okay, for research funding for government agencies, this is the one of the part, whether the products or whether the consumables that you are using inside the experiment, whether they can be harmful to the environment or not. You have to give a statement saying that it is not affect the environment too badly. Safety requirements, whether this carry since it's fundamental in nature, sometimes it may suddenly have a adverse effects, okay, unwanted effects. So you may have to have the safety requirements in place. So this fundamental research may include the safety requirements. Uh, Examples of this type of experiments. What are the types of experiments? So for example, I'm telling you, study of laser or infrared transmission. You see laser rays and all. If you want to in exotic materials, so in different kinds of materials, what is the laser rays or infrared rays, how they are transmitting in different new novel materials, exotic materials. So this kind of experiments, they involve the penetration of this laser or infrared rays. So they should not be penetrating through us, which may be harmful to human body. So you have to take precautions. That's what is mentioned when these safety requirements. Whether it has have any effect on the environment, you have to specify. Okay, so studies of genetic engineering and cloning. So replicating the same kind of a, a body is what we call it as cloning or genetical morphing. So you are trying to genetically morph certain things. So when you want to do such things, what are its effects on the environment? That is also becomes important. Okay. For example, if it is an open type, the example is study of boiling of fluorocarbons, study of combustion products for engines. So when you start combusting, so for example, in a lab, you are now trying to use different oils as petrol or as fuel, organic materials as fuel, and trying to find out what are the emissions that are coming out. This is not a proprietary item that can be easily published or it can be kept in an open access. Okay. So the first type of research or experiments are basically fundamental, which may be proprietary or research, and based on this kind of uh, constraints, we have classified them. What may be the differences between these two? The second one is the developmental work. The second one is mostly developmental work. What do you mean by developmental work? So it involves developmental work, the third and fourth in the table that I have shown. The third and fourth, they both comes under the developmental work and frequently be assigned to the average engineering professional. Okay. So an ordinary engineering professional is required to carry out this kind of an experiment. In short, a BTech or an MTech engineer is enough for carrying out the development, whereas a PhD is required for carrying out the fundamental research. Okay, so design protocol should be applicable to such projects since they are only an average engineering professional can carry out that. So the expectation, the procedure is already laid down. Okay, what are the steps involved is already determined. Okay, so whatever the design protocol that we follow is applicable to this kind of, it's not variable, it is a standard methodology that we will. Okay, though that will be our developmental work. Okay, so now how this developmental research work, company proprietaries, or if it is a company owning, if they are carrying out a developmental research work, and if it is open, so what are the constraints or how do we classify them is also shown in this particular table. I hope you can go through that. I have explained one, so I am expecting you people to go through it. So the most important things I am actually trying to explain here. So when it comes to the output publication, so internally restricted because it's so proprietary and they are trying to develop a product kind of a thing. Okay? So they cannot give out to publications and all. Open results, unlike until patented. So these are open results until patented or legally protected. So developmental research works are generally, we can say that they can be seen if you pay some money. Okay? You can take those results if you give some if you are following the legal restrictions imposed on that. Okay? You cannot easily look at how you are looking at the fundamental research. Open results cannot be published in a journal paper or something. These are results which are patented with a special company. You will say that it is patented. That means you are protecting the output by legal rights. So when whomever want to use that, they have to pay certain things to you, a certain amount to you. and then they can use the output results. So these are basically developmental thing. Both are, one is proprietary and other one is open results. The proprietary results, they will not give it to anybody else outside. But here we are confirming that under the patenting type of it. So design not specified, outcome specified, as within limits. So within certain limits, we will actually, we know what is what is going to be the outcome. We are not completely sure, but we are kind of expecting how it can be. We don't know what is the exact numbers and all, but we know that if this decreases, that will increase. That you know. Okay, when you reduce one variable, other variable will increase. That you know. But at what percentage it increases, how much variation it can show, that you are not very sure about it. Experimental separators designed or outcome or objective not specified. Sometimes it's the same thing. We don't use the same thing for even developmental research also. We necessarily not required to use the same apparatus. Sometimes we go for other. Outcome known or anticipated. Sometimes it's not always true correct that outcome is not known, just like in fundamental research. Sometimes we vaguely know what is going to come as an output. Okay? Method or procedure known or outcome unknown or surprises anticipated. Okay, so here also developmental research, sometimes we may know the methodology if that is comes under the open results, but proprietary type we don't know the methodology also. They don't give anything outside. Analysis and theoretical requirements, they are variable. For each experiment it will be different. Uncertainty analysis, as I said, it's a must to have this uncertainty analysis. And personnel requires special background, may or may not. It's not hard and fast rule that an expert should be there. As I told, any engineer, any average engineer can carry out this. Significant involvement of other groups or people, it depends, because you have developer output and then you have this finance, legal budget you have to have, and then legal rights. How do you patent that and all? So you need other groups of people also to be involved. Novel experimental design, depends again. Probably yes. Each experiment is different. So sometimes experimentally you have to design it. So that may be required. Expense limits are budget constraints, highly variable. Highly variable. That means it varies because it's all based on product based. So the companies invest a lot of money. So they may be varying it. It's not that it's free hand. You have highly variable expense limits or budget restrictions. Time constraints, usually rushed. They will not give you any time. That's why in industry, you will feel the pressure because the time limits are always imposed on a particular experiment. You are given a particular time and you are asked to give an output in the very next day. One of my experience in my laboratory, I will tell you, we have my project, my guide has got good project from the industry. So when we have done some experiment and we are ready with the results, people from the industry who actually partnered with us, they will come to the institute, they will look at this result and all. And finally, they will sit and analyze and they say that there is a small change required. And until 12 o'clock or 11 o'clock in the night, we will discuss the thing. And they try to leave by flight around 12 or 1 o'clock, they will leave by flight. And the very next morning at 10 o'clock, they will say that whether we have actually applied that, whatever the changes that they have made, whether we fabricated it or not, they used to call and ask. I used to be really surprised. See, last night they left, and how do they expect us to do in the very morning? Don't we sleep and all? But that's how the industry works. They have these timelines, and time is like the gold to them, unlike in the academic setting. Okay? Your pressure is very, so huge amount of money is involved, so time is also very less. Do you require to look at environment constraints? Yes, you have to. Safety requirements? Yes. For example, what are the examples of this kind of thing? You can see that semiconductor chip growth or manufacturing methods. This is one of the project, laser cutting methods in manufacturing. So, by a laser you can cut methods. So different materials, how you are cutting, what are the frequencies that you are, what are the wavelengths and frequencies you are using for cutting different materials. So each of them are same, the experiment is same, but product is different for which is being cut, and the frequencies and wavelengths are being varied. So any average person who knows how to do different laser waves, themes and all, they can use this kind of an experimental setup. Okay, so same example can be given for a development. I hope you are able to understand. The third one comes under testing. Okay, so what do you mean by testing? Okay, these are the experiments that require testing according to a code. Usually require very little design. So we don't design anything here. We are only testing it. After we give certain results, whether we will be testing using a particular code. So there is a order by which we are testing the actual results are following the same code or not. Okay, but what it is in what it requires is there is no design over here, but it requires significant amount of coordination. We need lot of coordination, so to ensure that the results that we have got out of this experiment match the code requirements. Okay? So that is the most important thing. That process which we use for doing this is called as testing kind of experiments. Okay, so the same design protocol discussion that we are carrying out will be applicable to all these kind of the rest of the other things. The final one is the just to want to know category of experiment. It is not simple as it may seem. Generally, curious inquiry, whatever how any particular basic and novice engineer who thinks that what happens if I vary this, it's just because out of your curiosity that you are asking these questions. Okay? So to just get that kind of thing out of your inquisitiveness, you have asked a question and you did a small experiment, and that sometimes lead to a profitable product development or modification. So there are things which you do it randomly just for the sake of getting some particular knowledge or out of your curiosity, and they suddenly give an important result which may be profitable. And those kind of experiments, we generally don't plan it very carefully and all, but what if kind of a scenario, it will happen. Okay, so it's just want to know category cannot be used in an industrial environment because that is more profit oriented. You cannot simply always sit and all think and suddenly you get some idea and I will use that. That will never happen in industry because each minute is important and they are profit oriented. So this kind of an just to want to know kind of a curious kind of research is not allowed in an industry-oriented environment. For example, how long does it take to boil a cup of water in a microwave? Okay, such kind of, because it requires certain cookware for such purposes. Okay, so specific object placement in commercial units, okay, or possible improvements in design of the heating cycles of the units. All these are the respective possibilities out of this query. So the query is how long does it take to boil a cup of water in a microwave? So you may look at the cookware, you may look at the placement of these commercial units, or you may look at the design of the heating equipment. All of this can be done. Okay, the very varying thing in a testing is basically you don't need to, because here in testing we don't need your experiment setups. So when you are not doing any experiment, you don't need to have the uncertainty analysis. Here we don't need uncertainty. Okay, doesn't be required. Okay, but here just to want to know, you have to decide this uncertainty again. Okay, so you please go through the rest of the things. I've talked about this part 3 and 4 also we have talked, and testing according to code or specified. You can see output publications are generally internal report because they are mostly We are following a code and all that is basically specific to a company. So internal report or report to regulatory agencies. Presentation requires, they are not very outside, it is a minimal. You don't need to keep on reporting the things. You are just looking at whether the results are following, the results are you have got have followed the particular code or not. An experimental apparatus designed as within limits. Outcome known or anticipated. We don't know because we are not doing any experiments here, so it is not applicable here. And then uncertainty analysis is required. This is what I'm talking about. This is not required. Personnel requires special background. Yes, usually trained for testing. Coding, whether to test it for whether the process has followed a particular code or not. So they have to know how this code has been laid down. So for that, trained people are enough. Significant involvement of other groups not required. Novel experimental design requirement, no. Pressure inspired instruments required are off the shelf, Experiment designed, execute only. We don't need to do that. We are only carrying out execution. We are looking at only the execution. So expense limits or budget, because we know for a testing code and all, the procedure we know. So it's just we are looking at the procedure. So generally the expense limits are all well defined. So this is the range. Within this range, this coding has to be completed, is well defined. Time constraints, uh, time constraints are not there because these are also usually well defined. These time constraints are also well defined. The next thing is environmental issues. Okay. Environmental issues, you have to test. Safety requirements, you have to test again. The final thing, what is the example of this kind of thing? So suppose you are trying to find out the calorific value of a food. So you have conducted calorific value of food, but whether you are following the standards laid down by ASTM, American Society of American Society of Mechanical Engineers or something, such kind of a society, it has given certain instructions that for finding calorific value, you have to follow this particular steps. So whether following what code, whether it's ASTM code or ASME code, which code based on which you are finding out your calorific value. Similarly, viscosity index. What is the viscosity of that particular material? So whether you are following ASTM norms or ASME norms, which one you are following? So based on that, you are explaining the people. So such kind of experiments we call it as testing or coding. Testing according to code or specified standards. Okay? So this is the third kind of research. And the rest of the things are testing according to accept method but not code. Testing for commercial purpose. These are all comes under testing only. They all follow a specified code. So they are all, you can look at these two in your free time. And the final one is just to want to know. As a curious thing, I told you, it's an informal report. You don't know to whom you are supposing. It's just an informal. So whatever the interesting thing that you observe, just you will say that verbally to a supervisor, sir, I found out this. So if you do an experiment, we will get some good results and also not presentation and all is not required. Outcome specified, and it depends on possibly experimental setups design we may use. Maybe we don't know, because already whatever experiments are available based on that you are actually doing. So uncertainty analysis required. Yeah, minimal uncertainty analysis. The simplest methods are enough. Okay, personal special background required? No. Significant involvement of other people not required. Novel experimental designs not required. Experimental design are executed off the shelf but may need special effects. So expense limits, we have low budget for carrying out because it's just out of curiosity. Time, very short time will be given. Space facility are requirements, no special time, space and all are required. Environmental constraints, this has to be taken out. And as I told you, the experiment, anything, how long does it take to boil a cup of water in a microwave? This kind of things we can share. So as a first part, we are looking at different kinds of research, okay, that we are following in the most possible environments like academic, industry, or industry oriented whether we are following certain guidelines laid down by the societies, whether we are following that. Likewise, we are having a look at the basic classification. Okay. So we also have what are the design factors. Now, first one is different kinds of experimental classification we have seen. Now we will also look at the design factors. What are the factors that design your that are actually constraining your experiments? What are those things? And then the factors which actually you have to follow while calculating the experiments or while designing the experiments, you look at that. Okay. Next one is what is a design protocol which can be generally applied to most of the experiments. And one example on that, how do we do this design protocol? How do we explain that? One example I will try to spend some time on. So this is the thing that we are going to look at in the coming classes. I hope you are able to understand the basic classification of different kinds of experimental research or research. Any questions? If it is kind of boring, you please let me know so that I'll try to make it simplified. I want you to actually understand the different things which are involved in this particular thing. That's why I spent a long time on one particular thing. If it is kind of, sir, we can make it short, I can put it as a nutshell, in a very small, simplest way also I can speak. But you as future engineers, you should know when you are doing an experiment under which classification this comes. While designing the protocol, you should know whether it comes under fundamental research or developmental thing or just a code you are trying to follow or just out of your curious thing you are finding. So while defining this design protocol, you should know under what classification our research falls. That is most important. So that's why I spent a lot of time on this. I hope you are able to understand. Those who are in between, it's like not able to concentrate kind of a thing. They can just watch the recording whenever you get some time. Okay, I'll share the recording. Then you can just understand the time, understand what I was trying to explain. Any questions? Please feel free to ask.
No question.
Okay. Is it okay, Amarnath? I mean, it's not boring, I think, right?
No worrying, sir.
Yeah. So the next class we will try to see the actual design protocol, and the next class we will also look at another two classes. One more class we will see how, for one experimental setup, how do we lay down the protocol? How do we follow the protocol while designing it? It would be interesting for you because you are future engineers and you may also ask to do experiments, and this will be a good platform to understand how do we design these experiments. Okay, so if you don't have any other questions, then I will try to take leave from you. So thanks for attending the class. And Kalyan, if at all you have any chance of in tomorrow, if you have a free any session, then I will try to take that class. Tomorrow is Wednesday, no? So I can take one class if it is possible because we missed the last class.
Yes, sir, I will inform you.
What, Kalyan?
Yes, sir, I will inform you, sir, if you have any.
Yeah, if anything is there, just inform by tonight so that I will be ready.
Okay.
Okay, guys. What about the exam, minor exam? Will you be able to write it on tomorrow, or you want it to have on Saturday?
We have one minor GD tomorrow, but yeah, like GD people wanted it to be shifted on weekend on Saturday, but the other people don't want that, so we don't know.
So please come to one single platform. Most of you have voting or something. Also, we have to coordinate with the A section people also, right? So try to coordinate with them also, and finally come to a conclusion and let. Okay, I'll try to take the question paper by today itself. So it's up to you whether you want tomorrow at what time. Suppose if it is tomorrow,
Evening.
Evening?
Af-
6, huh?
uh,
Evening 6.
evening 4 we are free, sir. After
Evening?
4 we are,
Evening?
after 4 we are free, sir. Evening after.
Okay. Anyways, I'll put around 6 o'clock. Okay, 6 to
Okay.
6:30. After having your tea and all, you can write things. Okay, so just let me know, Kalyan, you after contacting with other people and all.
Yes, sir. I will let you know by
Yeah.
evening.
Sure. Okay. So please
So
take
how
care
about
of.
mid papers? Like,
Yeah,
aren't they
because,
correct?
no, it was not corrected, Jayesh, because I was stuck with some other departmental work. We are trying to improve the measurements lab, and suddenly there was a fund that has come, and
Yeah, it's fine, sir. Just asked.
I'm really
Thanks.
sorry for that because
No,
other
it's
section
fine,
people
sir.
already had, but I'll try to finish. Okay,
Okay, sir.
right. Okay, and Thursday you have this skill test kind of a thing.
Yes, sir. Till okay.
Yeah. One more student has actually mailed me saying that his father health was not good, and because of that, he missed the minor skill test one. Do you know him, Kalyan?
Maybe from section A, sir.
Section here.
Yes.
Okay. Huh?
I will let you know about him.
Yes. Okay. Whether he has inquired and informed it to the CR or not, that is what the information that I want. And this Thursday, you will have a lab directly in the laboratory. We will take the report. You
yes,
come
sir.
there. You come there. If any change is there, I will let you know. But mostly we will go to the lab. Okay.
Yes.
Right. And I also increased the time to up to Friday because I felt that I actually shared because I shared the whole folder before the lab itself. On Thursday around 11 o'clock, I shared, but unfortunately, it has not come to your emails because I shared in a group on your group mail. I don't know why it has not come, but I came to know that it was not being shared after 2 days. So I'm just extending that until Friday 12 o'clock. So you can submit up to Friday 12 o'clock. All right.
Yes.
Okay. I will also show you did I send you the marks up to 5 and 6, right? I have shared it, right? 7 and
yes,
8.
sir.
7 and 8 I
7
have
and
to
8
share.
are not.
Okay.
Yes.
I will share that. Okay.
Okay.
All right. Take care.